Hi, today we'll be coding a solution to this challenge, that is, get this result using a single div, no pseudos, at most 5 CSS declarations, no JS, no SVG, no images other than CSS gradients, and no value lists longer than 4 items. That is, we cannot have a background with 5 layers or more. We already have our div. We're going to maximize the CSS panel because we're not going to write anything but CSS. We're going to have this plain line block. Does anyone still use this for anything? We're going to use it. And next step, we're going to decide upon dimensions for our div. Now, at first, we're not going to consider the corner roundings. We're going to consider this outer triangle with pointy vertices, just like we have right here. This one starts from 3 o'clock, not from 12 o'clock like we want. But hey, what are dev tools for? So we have our SVG, and then we're going to have rotate minus 90 degrees. Okay, that does it. Let's close DevTools, and this is pretty much the triangle we want. Okay, we're going to draw perpendiculars from each of the vertices onto the opposing edges, and these perpendiculars are going to split the opposing edges into 2 equal halves, because this is what happens for equilateral triangles with all edges equal and all vertex angles equal. Okay, so these perpendiculars are also going to split the vertex angles into 2 equal halves. Now, a triangle, right? The sum of the angles in a triangle is always 180 degrees, right? So if we have 180 degrees in total and we have 3 equal angles, I'm not sure if I'm going to manage, but yeah, I managed. Okay, and if you have 3 equal angles, that means each of the angles is 60 degrees. Okay, so each of the angles is 60 degrees, and these lines, right, split them into 2 30-degree angles. Okay, now all these 3 lines intersect at the same point, and this point is both the center of this big outer red circle, which is called the circumcircle, and it passes through the vertices, through all 3 vertices of the triangle. So it has the vertex points in common with the triangle, okay? But the center point is also the center of this small inner blue circle, right? And this is called the incircle, and it touches each of the edges at one point in the very middle. Okay, now this red segment, the bigger red segment, this is the circumradius, the radius of the big red circle. And this smaller segment is the inradius, the radius of the smaller incircle. Now, we are going to have our div tightly fit around this big outer circle. That means the width and height of our div are going to be equal to the big circle diameter. So they're going to be twice the circumradius. So if we set here our circumradius, something like this, right? Then we're going to have, and just so that we can see the boundaries, we're going to set a box shadow, 0 offsets, 0 blur, doesn't really matter, some color. Okay, and now we can see the boundaries of our div element. And having done this, we are going to want to create a triangle. And how can we create a triangle using a gradient? So we're going to have conic-gradient. Finally, we have autocomplete for that. And we're going to go from red to transparent. Or let's better go to gold at first, and then we're going to change that. So you can see how we start from 12 o'clock with red, right? And we go around the full circle. We go a full circle, 360 degrees, and we find that we have that gold. Okay, but in our case, we are not going to want to start from 12 o'clock. We're going to want to start from this, so let's say, okay, our conic gradient, the start line is going to be this line. Now, if we go from 12 o'clock to 6 o'clock, pointing down, right? Pointing down like this vertical line does, we have 180 degrees. But then we need to, in our case, we need to go back by 30 degrees, because 30 degrees is half the vertex angle, right? You can see right here, 30 degrees is half the vertex angle, because the vertex angle is 60 degrees. The sum of the angles in a triangle is always 180. And for a triangle that has all vertex angles equal, that means 60 degrees per vertex angle. Okay, so we are going to start from 180 degrees minus 30 degrees, that is 150 degrees. So we start from 150 degrees, right? You can see it there. And then we're going to go with red for 60 degrees, and then we're going to have a sharp transition. And we get a sharp transition if the stop position, this stop position right here, is smaller or equal to this one. So we could put 60 degrees as well. But then if we change this value from 60 degrees to something else, then yeah, it's not going to work. But if this value is smaller or equal to this one, we're always going to have a sharp transition. And 0 is always smaller than every positive number. So yeah, we're going to use 0 there. So we have a sharp transition. And that's pretty much our triangle, but we don't want it positioned there. We want it to start from the top middle. So we're going to have this at 50% horizontally, 0 vertically. So that's the point around which we have our conic gradient. Okay, and we're going to go back to transparent there. Right, and we're going to want this to stop at the height of the triangle. Now, the height of the triangle is the sum between the circumradius and the inradius. We already know the circumradius, right? Because it's half the div. But what about the inradius? Well, let's get here. So let's say that in this case, right, we're going to have, again, that SVG, and we're going to have rotate 30 degrees. Okay, that looks nice. Okay, now you can see how that OV, that's the circumradius, OM is the inradius, and OM over OV, right, is basically the sine of this 30-degree angle, because it's the opposing edge over the hypotenuse. Okay, so OM over OV is the sine of 30 degrees, but we know the sine of 30 degrees. We can get it from a table, or we can just compute it in a calculator or online, whatever. The sine of 30 degrees is 0.5. So basically, we can get to the inradius. Let's actually compute it using trigonometry. And for that, we're going to need to import a SAS module. I cannot type. Okay, now here we're going to have the inradius, right? Let's get the vertex angle is 180 degrees over 3 for a triangle. Then we're going to have the half angle, which is going to be half the vertex angle. That should have been 0.5. Okay, and then we're going to have the sine, which is going to be the sine of the half angle. And here we're going to have basically the circle. So the inradius is going to be the circumradius times the sine of the half angle. Okay, and then the height is going to be the circumradius plus the inradius. So here we are going to position this at 0, 0, so top left corner, right? Horizontally, the background size is going to stretch all across the div, 100%. And vertically, we're going to have the height of the triangle. And you can see it there. And then we're going to have no repeat, like that. Okay, so now we have our nice triangle. Next up for the rounding. So now here, the cool thing about SVGs is we can edit them and we can change various things in there. Okay, something like that. Okay, let's we're going to add some things at the end, but now I want to show you something here. We're going to assume that the border width and the rounding radius, right, are going to be equal. So if we draw a perpendicular from that point to the vertex of the inner triangle, that is going to coincide with the center of the circle that gives us the rounding arc. Okay, so if you draw a perpendicular from that point, which is the center of the circle, if you draw a perpendicular onto this outer edge or onto this outer edge, this perpendicular is going to intersect the edge at the point where we connect the straight line to the arc in both ends. Okay, so let's create that circle, right? We're going to just add it somewhere there. We don't have add element, but we can duplicate element, and then we can just edit that, right? So we can have circle, let's say like that. Okay, that's going to be our circle. Now we're going to have stroke medium violet red, let's say, fill none. Okay, and then we're going to have stroke with, okay, and can also set stroke dash array 3. Let's make this deep pink. Yeah, it's going to be more different from the edge. And let's also duplicate, right? Let's have a different element here, edit as HTML. So we're going to have line, right? X1 is going to be the center CX, right? 200, and X2 is going to be that value plus the radius, right? 287, like that. And then we're also going to have transform rotate by 60 degrees around that point 200, like that. So now we are going to have stroke orange, stroke width is going to be 2, and right. Okay, and I guess we could just clone this, and this is going to be rotated, so the other way, minus 60 degrees, right, is going to give us. Okay, let's just close this for now. So that is going to be our rounding circle, right? So that's basically going to be the corner rounding. That's going to be the radius of the rounding, and also the border width, which we're going to set somehow so that so the border width is going to be 0.25 times the circumradius. We're probably going to want it smaller than that, but yeah. So we know that border width, we know this radius, okay, we know this angle, so we can determine the distance from that point to the vertex, right? So let's actually bring up DevTools again, and let's say that this rotation is going to be minus 90 degrees. So for example, something like that. So we're going to want to compute the distance from the top, right? So basically, we're going to have that the border width over that distance is going to be the sine of that angle. So let's get that distance from the top, dy. That's going to be the border width over the sine of the angle. So now, let's say that we're going to have a radial gradient circle transparent up to that border width, right? And then blue, let's see it. Okay, let's make this RGBA blue, something like that. Okay, now we're going to want to have this circle is going to be at 50%, and that dy, okay, like that. And then we're going to want it only up to those points, right? So we're going to compute the distance from the vertex. Now the distance from the vertex is going to be the distance from that point where the perpendicular falls, from there to the vertex. Now that is going to be dy cosine of 30 degrees, because that distance over the hypotenuse is going to be cosine of 30 degrees. So we're also going to have something similar here. Instead of sine, we're going to have cosine, and we're going to have the distance from the vertex, which is going to be dy times cosine, right? Okay. So then, knowing that, we are going to want to compute the distance from the vertex to where the perpendicular from there falls, right? And basically there we're going to have another right triangle, but in that right triangle, that is going to be the hypotenuse. So the size around the y-axis, along the y-axis, not around, along the y-axis is going to be that vertical distance times cosine again. So here, when we're going to set the size, again, we're going to position it 0, 0. Horizontal size is going to cover the entire div, so it's going to be 100% of the div, and then we're going to have that size. Let's see it. Okay, now you can see it there, and then again we're going to have no repeat. Now you can start to see a rounding there, and we're going to use a similar tactic for the other two corners. Now we need to get the x-coordinates of the other two corners, because we know the y-coordinates. The y-coordinate with respect to the top is the circumradius plus the inradius, which is basically the height. Okay, but what about the x-coordinates of those two? Well, those x-coordinates, right, are going to be the circumradius, right? So up to here, this is 0. Here, the midline is the circumradius. And from one, we're going to subtract half the edge length, and to the other one, we're going to add half the edge length. But how much is the edge length? Well, there we have a 30-degree angle, and we know this height, right? So we could say that the edge length, we're going to use the tangent of 30 degrees. Or alternately, we could compute half the edge length from this triangle, OMV, right? So in this triangle, the circumradius is the hypotenuse, and half the edge length is that MV. So it's going to be the cosine. So half the edge length, right, is going to be circumradius times the cosine. Okay, so knowing that the coordinate of that vertex 1 is going to be the circumradius minus that, and the coordinate of the other one is going to be the circumradius plus half the edge length. So now we know that coordinate, and let's change this rotation once more, right? Change it to 30 degrees. Okay. And some dimensions there are going to be very similar. So the horizontal size is going to be that distance from the vertex, and the vertical size is going to be the distance from that perpendicular onto this bottom edge. Now, how much is the distance of that perpendicular? Well, this total angle right here is going to be 60 degrees, right? And we know the distance from the vertex, and if we draw a perpendicular, that's going to be a right triangle. So it's going to be this distance from the vertex times cosine of 60 degrees. So SY1 is going to be the distance from the vertex times cosine of 60 degrees, but cosine of 60 degrees is sine of 30 degrees. So that's our vertical size for those. So now let's take this and this circle is going to be at 100%, right? This is going to be the size minus the border width, which is the radius, right? And this one is going to be positioned at the vertex, and the height minus the size, okay? And we're going to interpolate that so that SAS doesn't attempt to create, okay? And the size is going to be like that, okay? Right. No, cosine, sorry. Right. Okay, so right, so this was the sine of 60, so if that is the hypotenuse, the distance to that point, right? And if we draw perpendicular, right, this one is going to be the hypotenuse times the sine of 60 degrees or the cosine of 30 degrees. That's fine. Okay, so it was cosine. Sorry about that. Okay, now next, for the other one is going to be very similar. So in our case, it's going to be okay, and this one is going to be x2 minus dv, right? So like that. So they arrange nicely. I'm going to want to get this out of here and put it here so that or maybe like that. Okay, I think they make more sense like this. Okay, so now something that we could do is subtract those solid parts, those blue parts, subtract them from the red. We can't quite do that with backgrounds, but we can do that with masking, and specifically mask compositing. Now, I wrote an article that goes into a lot of detail here. So what we're going to use here is the subtract. Basically, here, wherever the top layer is fully transparent or whatever the bottom layer is fully opaque, right, the result is going to be transparent. So if we make the entire red, right, fully opaque, and we also make the entire blue fully opaque, and we subtract the blue from the red, right, it's going to give us what we want. So let's say mask there, and then we're going to have just a random background, right? We're going to have those, we're going to take the conic gradient, right? You can have those, and yeah, let's get rid of the RGBA. I should have done it in all three places instead of doing something silly like this. Okay, like that. We can turn the blue into red, it doesn't matter. As long as it has an alpha of 1, anything works. Okay, so we have those parts. Then we're going to have conic gradient, subtract, right? Okay, but only this one right here gets subtracted, which means that we need to have the add, which is basically just the normal, just dropping them one on top of the other, and yeah, so you can see how now we have that nice outer shape. Okay, now having done this, we can have a nicer background. So for example, we can have linear gradient from white to black. So something like that. And this black is going to go up to the height. Okay, much nicer. And then we're going to add another conic gradient. And this one is going to start just the same. So it's going to be very similar to what we have right here. Like that. Okay, and except it's going to start from that point right there, right? And that is vertically at dy. And we're going to want this to be white, right? And we're going to want the background size to be, so cover everything fully horizontally, and then we're going to have the height minus the border width. Okay, right, so something like that. And the next step is going to be blend these two layers. Now, I also wrote an article about blending, about two blend modes, difference and exclusion. And let's just look at one of them. So here you can see for difference, yeah, something's wrong with the layout in this demo. Layout is not my strong point, so sometimes it just breaks in interactive demos that I make. Okay, now you can see two layers that are separated, and in this case you have something that looks like what we have here. One of the layers is fully white. So when we have something that's fully white, one of the layers is fully white, then the result of the difference blend mode is going to be the other layer inverted. Now you can see them when they overlap. So if one layer is white, the resulting layer is identical to the other layer inverted. Now, the article goes into a lot of detail and it explains the mathematical computations behind and all the formulas and stuff. But we're not going to look at that. Just know that we're going to use background blend mode difference. Okay, but this looks a bit too dark and not quite what we wanted. So one way to do that is add one semi-transparent layer on top with a normal blend mode. Again, this is something that I discussed in detail, and you can just, if you want a certain resulting color, in this article you're going to find the formulas that let you get the desired alpha, so that you get the result that you want, the resulting color that you want. So these are basically adventures in CSS semi-transparency land. What is the result that you get when you add a semi-transparent layer on top? So yeah, check it out. But in our case, we're going to go with something pretty simple. So we're going to have a linear gradient, HSL. This one is going to be 0% saturation, and we can say that we have 100% lightness and 0.5%. This is probably going to make it too light. And of course, as I mentioned earlier, we're going to need a normal blend mode. Right, okay, so something like this. Okay, as I said, this is going to make it too light, and of course we can decrease the lightness here as well, so we could have something like 85. And of course that border width is too thick. We could make something smaller, something like this. Like this. So yeah, I'm not going to tweak things any further. I'm going to leave it at this. I hope you've enjoyed this video, and if you like the work that I'm putting out for more than 10 years now, and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of one-time donation, or you could at least share this to show the role what can be done with CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and I'll see you next time.